Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 3 in the JWT attacks module titled JWT Authentication Bypass via Weak Signing Key. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs, and then do a search on JWT labs and select lab number 3 titled JWT Authentication Bypass via Weak Signing Key. Alright, let's get started. This lab uses a JWT-based mechanism for handling sessions. It uses an extremely weak secret key to both sign and verify tokens. This can be easily brute forced using a word list of common secrets. To solve the lab, first brute force the website's secret key. Once you've obtained this, use it to sign a modified session token that gives you access to the admin panel @/admin, and then delete the user Carlos. You can log into your own account using the following credentials, and we're given credentials of a regular user account. Alright, so the goal over here is to brute force the website's secret key. We're going to use this word list to do that. Once we brute force the secret key, we're going to modify the session token so that it becomes an administrator session token, and then we're going to sign it using the secret key that we brute forced. And then from there, we're going to access the admin panel and delete the Carlos user. Alright, let's access the lab. Now, notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. We will be using the JWT editor extension, so if you haven't downloaded it in the previous labs, I highly recommend that you go to the extensions tab and go to the BAP store subtab and download it from there because we're going to need it for this lab. Alright, the first thing we're going to do is log in with the regular user account credentials. So the password was Peter, hit login. Now notice over here that our requests are being highlighted in green. That's done by the JWT editor extension. And what that means is that there's a JSON web token in these requests. So if you look over here, this is our login request. It's a post request. And then if you go down over here, it takes in the CSRF token, the username, and the password. If the username and the password are correct, then it sets a cookie called session for the user that has the JSON web token for that user. And then from there, it sends it with each request. So we're going to go to the My Account page and send this to Repeater and work from Repeater. All right, let's make this bigger and let's move it to the other side. And we don't need this. Make this a little bit smaller actually, and this a little bit bigger. All right, so if we hit send right over here, you could see that we access the My Account page for the regular user. And the way that the application knows that we're trying to access this regular user's account page and we're actually authorized to do that is through this JSON web token. So if we look over here, this is the decoded version of the token. We've got the header, the payload, and the signature. And in the payload over here, you could see the subject contains the username of the regular user. And since it's properly signed and the application is verifying that, then it trusts that this is the cookie of the regular user. And so it allows us to access his account. Now, when it comes to JSON web tokens, like I said in previous labs, there's quite a few attack vectors that you can check for. The first one is to check if the JWT signature is verified. So we did that in lab number 1. The way you would do that is just change a few characters in the signature and hit send. If the application still allows you to log in as that user, that means that the signature is not being verified. We're going to assume that we checked this for this lab and it didn't work. The next thing that you could check for is if the application accepts an unsigned JWT, or in other words, the non-algorithm attack. So that was done in lab number 2, where we changed the algorithm to none, and then we changed the subject to administrator, and then from there we removed the signature portion of the JWT and hit send. And if the application supports the none algorithm, then you could exploit this vulnerability to compromise any account on the system. Again, we're going to assume that we tried this attack and it didn't work. So the next thing that I try is to check for weak signing key or brute forcible secret key. So this specific attack vector only works for symmetric algorithms. And as you can see over here, in the algorithm field, you've got HS256, which stands for HMAC with SHA-256, which is a symmetric keyed hashing algorithm that only uses one key to both generate the signature and to validate it. In the previous labs, we saw RS256, which stands for RSA signature with SHA-256. That's an asymmetric algorithm that uses public-private key pair. The private key is used to sign the token, and the public key is used to verify it. Now, this specific attack vector only works for symmetric algorithms because you get to choose the key in a symmetric algorithm. And so if you choose a weak key, or let's say a weak phrase such as password for the signing key, then it's possible that you could brute force it. Whereas when it comes to public key cryptography or asymmetric algorithms, you have two key pairs and those are generated. And so it's not possible to brute force them. Technically, you could brute force them, but it'll take thousands of years. And so they're considered not to be vulnerable to brute force attacks. All right, since we do have a symmetric algorithm, we need to check for this specific attack vector. And the way we're going to do that is we're going to take the JSON web token. Let's copy it from here. And then we're going to perform an offline cracking attack using a tool called Hashcat. So the tool should come pre-installed in Kali Linux. However, if you don't have it installed, you could just regularly install it from the command line. I'm going to go to terminal, new terminal over here. Again, you could just use the command line to do this, but I'm going to do it from Visual Studio because I have all my files in this specific directory. The command to do it is hashcat. And then we're going to say -a, which stands for the attack mode, and it takes a specific integer. Now you could see over here that I've done this before, and so it's already highlighting it for me. But the attack vector that we're going to use, or the attack mode that we're going to use, is 0, which means straight, and that's essentially that it's going to take in a word list and then perform an attack using that word list. So it'll read line by line from a text file and see if you use that specific string in that specific line in order to sign your JSON web token. The next thing we're going to add is -m, which stands for hash type or mode. And for JSON web tokens, the hash mode is 16500. You could easily find that in the help page, or if you just Google hashcat and then the hash type for JSON web tokens. And then we're going to take in our JSON web token, and then we need to pass the path for our word list, which it's going to use in order to see if the user used a weak secret key in that specific word list. Now, if we go back to the exercise over here, Portswigger did provide us with a word list of common secrets, and it's on GitHub. So you could download it from there, click on download raw file, and then download it. I've already downloaded it and it's in this and placed it in this directory right over here. And so I'm just gonna say jaw.secrets.list. Now, of course, if you have it in a different directory, you need to include the entire path over here for it to work. All right, so let's take our JSON web token. Now, the nice thing about this is that it's all done offline, and so you could spend hours, you could spend days, you could spend weeks trying to crack this token, which is what attackers do. And the application developers would never know because you're not actually performing this attack on the application itself. And so there is no logging that is happening over here. Now, I don't want the lab to time out. And so I'm just going to fix this because for some reason it got ruined. And I'm just going to hit enter again, make sure it didn't time out. Okay, perfect. And I'll make this a little bit bigger. And then we're going to hit enter. Now, Hashcat is going to run and then it's going to try and identify the key. I usually don't run Hashcat in a VM because it'll crash my VM. However, the secret key over here is really simple, and so you could see it automatically was able to figure it out. And if we make this bigger right over here so that it's easier for you to see, you could see that it cracked it, first of all, and that the hash mode is 16500, which is for JSON Web Tokens. And the secret is just secret 1. So this is our secret key that is being used to sign the tokens. So we're going to copy that. Now the next step over here is to use that secret key in order to sign our modified token that we modified to work for the administrator account. And so to do that, there's quite a few steps. Like I said, we need the JWT extension, which over here I already have a key. Let's delete it. Now, before we generate a new symmetric key, the first thing we're going to need to do is take our secret key that we just identified and then encode it as base 64, copy that, go to the JWT extension, click on new symmetric key, click on generate, and then from there in the key field, so the K field, add our encoded secret key that we just identified, click OK. Go back to repeater, and then repeater over here, click JSON Web Token, and I'm just going to send again so that it doesn't time out on me. But we go back to JSON Web Token. We're going to change up our subject to administrator. And then we're going to click on sign. Now for the signature over here, it'll give us all the different signing keys that we've generated. In this case, we only generated one. So I'm going to click on that. Make sure you say don't modify header because we want it to be the same. Click OK. And here we go. So what it did is essentially it's now using the administrator as the subject, and then it re-signed the token. Since we are signing it with the legitimate secret key, which we were able to crack, when the application receives the request to /admin, it will verify the signature, it'll identify that the signature is correct, and so it should allow us to access the admin panel. Let's hit send, and here we go. So it should say 200 OK, and if you render it, we're able to see the admin panel where we can delete users. Now let's go to raw and look for the Carlos user. So this is the path to delete the Carlos user. Let's copy it, paste it in here, hit send, and we get a 302. And you could see over here it says congratulations, you solved the lab. Now if we go back and visit the admin panel, you should no longer see the Carlos user. All right. So we successfully completed the exercise by exploiting the vulnerability manually. And when I say manually, I mean we manually used certain tools like Hashcat and then the JWT extension. We usually script our exploit, but because we are using other tools, we're technically already scripting our exploit, just using other people's tools. And so we won't be scripting the exploit for this lab. In the next lab, we'll look at another case of a JWT attack.